In this video, I wanted to go ahead and prove why x to the 0 power equals 1. So when it comes to exponents, we know a few things. For one, we know that when we say something like x to the second power, we really mean x multiplied by itself twice. So that means the same thing as x times x. And so when we say x to the third power, for example, we mean x times x times x, x multiplied to itself 3 times. So how do we get from this, what we already know, x squared meaning x times x, and x cubed meaning x times x times x, how do we get from that to somehow showing that x to the 0 power equals 1? That seems a bit strange. Well, here's how we can do that. So let's start with x to the third. And let's say I want to move from x to the third to x squared, right? Well, I know that x to the third means x times x times x, and x squared means x times x. Right, so how do I go from here, x times x times x, to x times x? Right, how do we go from x cubed to x squared? We do that by dividing by x. Right, we know that's the case because if we are increasing the exponent by 1, we're multiplying by an additional x. But if we're going backwards, if we're going from x cubed to x squared, we do the inverse of multiplication. What's the inverse of multiplication? What's the backwards of multiplication? Division. So we are dividing. So in that case, x times x times x divided by x gives us x times x, or x squared. Okay, so let's try that again. This time, we'll do x squared going to x to the first. Right? Again, we know that if we're moving our exponent up by 1, we multiply by an additional x. Right? We know that x times x squared means x times x. X to the first just means x. X to the first means x. And we're going down one exponent. So we're not multiplying by an additional x, because that would be increasing by an exponent, but we are doing the inverse of that. We are decreasing by an exponent, which means we are dividing by x, because division is the inverse of multiplication. So x times x divided by x just gives us x, this x over here. So we know that that checks out. And so what about x to the first to x to the 0 power? Well, we already know what x to the first is equal to. That's equal to x. People say that x to the 0 power is equal to 1, but we can't say that's true yet because we have to prove that. That's what we're trying to prove. And so the question is, how do we go from x to the first to x to the 0? How do we show that x to the 0 is actually 1? Well, notice that we've been moving from x cubed to x squared, and by going down one exponent, we divide by an x, right? Same thing with here. We have x squared, and we're trying to move from x squared to x to the first, so we divide by another x, right? Because division is the inverse of multiplication. And so what about this? Well, we just follow the same pattern. X to the first means x by itself, and if we're moving down by one exponent, then we divide. And in this case, we're dividing by x. Well, what is x divided by x? X divided by x is equal to 1, because any number divided by itself is equal to 1. And so for that reason, we know that x to the 0 power is actually equal to 1, which was what we were trying to prove. Now, just for fun, we know that x to the 0 power is equal to 1, right? What about x to the negative 1? Right, well, we know that x to the 0 is 1, and we're decreasing by an exponent, which means we need to divide by x. So in that case, x to the negative 1 is equal to 1 over x. And similarly, x negative 2 to the negative 2 power is equal to 1 over x times x, which means the same thing as 1 over x squared. So That's what that means here. But that was just for fun. Here, our only goal was to prove that x to the 0 power is equal to 1. And so what this shows us is that this here, that x to the 0 equals 1, is not something that we just believe because teachers tell us so. It's not something that we believe because mathematicians make that up. There's actually truth to why x to the 0 power is equal to 1. And it doesn't seem immediately intuitive, but once we think about what exponents actually mean, then this starts to make a lot more sense. So I hope this was helpful. Thank you.